Hello, guys, it's me. I bet you thought you didn't have to listen to me, but you do. This is just a quick little review for us to go back over how do I find the distance between those ordered pairs. So let's get started. I think you probably already have this down pretty well. What are the coordinates of these two ordered pairs? For A, remember I'm always going to start on the x. I'm going to go from the origin, which is 0, 0. I'm going to go over to 2 and up to 3. 2, 3 are the ordered pairs. And for B, I start again at the origin. I go over to 8 and up to 3. 8, 3 are the ordered pairs. Now, what is the distance that separates point A from point B? And that's pretty simple. I can simply count the points 1, 2, 3, 4, 5, 6. There are 6 units between A and B. Or, if I take a look here at my ordered pairs, do you notice how these 3's are the same? Let's just ignore them. How could I use 8 and 2 to get the answer 6? Well, I know that 8 minus 2, and in this case I have it written as the absolute value of 8 minus the absolute value of 2 is equal to 6, which is a true statement. That's pretty easy. Let's try another one. Here I have point A at -8, 5. And again, I start for point B at the origin, and I have -4, 5. Let's take a look at those two ordered pairs, -8, 5, and -4, 5. And I notice that the y coordinate is the same. So I'm going to ignore those, and I'm going to look at -8 and -4. And over here, I can see these two are in the same quadrant. So how many points separate them? Well, I could simply count, again, the units between A and B, 1, 2, 3, 4. Or I could take the absolute value of 8 minus the absolute value of 4, and I still get the answer 4. Just a quick reminder, absolute value is always positive, so -8's absolute value is 8. 8 minus the absolute value of 4, which would be 4. 8 minus 4 is 4. Wow. Have you noticed that when the ordered pairs are in the same quadrant, we subtract either the x or y variable that is different? Let's see if this always works. Now this time I have point A here at -4, -4. And I have point B at -1, -4. So my coordinates are -4, -4, -1, -4. And like I said before, we're going to take a look at these. I notice that my x's are different, but my y's are the same. So I'm going to ignore my y's and just take a look at the x's. Now, before we counted, which we could still do, 1, 2, 3, but we also subtracted the absolute value of -4 minus the absolute value of -1 is equal to 3. This is kind of simple. Let's try one more. Here I have point A at, starting again at my origin, 10, -4, and point B at 10, -9. So my coordinates are 10, -4, 10, -9. I notice that my x's are the same here, so I'm going to cross those out because I'm not going to use the ones that are the same. And I'm going to look at -4 and -9. And I am going to subtract their absolute values. But this time I want to make sure I start with the one that's going to have the largest absolute value. And -9 has an absolute value of 9, which is larger than the absolute value of -4. So the absolute value of -9 minus the absolute value of -4 is 5. And if I count here, 1, 2, 3, 4, 5, well, by gosh, I'm getting the same answer. This is pretty easy. I wouldn't even need to have the coordinate plane here to help me. I could just subtract either the x or the y, whichever is different. But what happens if the ordered pairs are in different quadrants? Do you think I'm still going to subtract? Let's check it out. Here I have point A at 10, 3. And I have point B at 10, -9. So 10 and 3 and 10 and -9. I'm going to go ahead and cross off the ones that are the same, which was the 10, the x coordinate. But if I go ahead and count here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, if I subtract 9, the absolute value of 9, negative 9, and 3, I'd get 6. That's not 12. So I don't think I'm going to subtract. You know, the opposite of subtraction is addition. What would happen if I added the absolute value of 9 plus the absolute value of 3? Well, 9 plus 3 is 12. So if my coordinates are in different quadrants, I add them. That's kind of making sense. But let's check out a couple more ordered pairs that are in different quadrants to make sure we're doing it right. Here I have A at 5, negative 3. And I have B at negative 4, negative 3. So my ordered pairs are 5, negative 3, and negative 4, negative 3. Well, just like we did before, I notice that my Y's, they're the same. So I'm going to cross them off. But 5 and negative 4 are different. They're not the same number. So I'm going to add their absolute value. I can tell just by looking that they're in different quadrants because 5 is positive and negative 4 is negative. I move different directions for the positive and the negative, so they couldn't be in the same quadrant. Therefore, I'm going to take the absolute value of 5 plus the absolute value of negative 4 to get the answer of 9. And to check myself, I'm going to go over here and count. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got the same answer. So when my ordered pairs are in different quadrants, I add them. When my ordered pairs are in the same quadrant, I subtract them. Same, subtract. Those start with the same letter, same and subtract. Whoa, this is pretty easy. I don't know about you, but I'm thinking I kind of understand this. And I'm going to try one more just to make sure. Here I start at my origin again, and I have negative 7, 7 as my ordered pair for A, and negative 7, negative 7 for B. I better look at this really carefully. Here I notice that my x's are both the same. They're both negative 7. So I'm going to cross them off. I don't need them. But 7 is different than negative 7. And because one's positive and one's negative, I know they're in a different quadrant. So therefore, I know I'm going to add. The absolute value of 7 plus the absolute value of negative 7 is 7 plus 7 is 14. Wow, this is super simple. We are Team Awesome, and I think you're ready to give it a whirl all on your own. So you're going to stop the video right now, and you're going to try some of these that are just like what we did. Only thing is you're not going to have a coordinate plane to count. So what you need to remember is if the coordinates that are different have the same sign, see all those S's? Subtract them. And if the ordered pair coordinates that are different have opposite signs, one's positive, one's negative, add them up, total them up. If they're different, total it up. Got it? I think you do. Let's see if you can do these problems on your worksheet.